The Leave plan of room specialists has tracked down that using our new 101 billion toy, it will be a very long time before that undertaking transforms into a reality. On the remote possibility that it goes as planned, the outing to Proxima B will take around 20 years. So, reasonably, it will be a few years before we can insist if there is certain life on that planet. The deeply rooted question of whether we are truly alone in this universe persists. The James Webb Space Telescope has discovered some shockingly humanesque things far away from Earth that lead us closer to the answer. Our mission for life outside of us has been uncontrolled throughout every human progression to such a degree that we have a considerable number of media works and speculations with respect to this matter. Our wonder concerning our spot and loneliness in the universe has been consistent. It is ingrained inside us to search for a mate continually, regardless of how outcast-like we might be. We might be getting progressively closer to the answers we really need, but are they truly the answers we are looking for, or are they simply more alarming? Join us as we examine the most recent discovery in the areas of systems and planets on the excursion to find something we likely will not be prepared to notice lights far off. Specialists have found what could be the most groundbreaking revelation in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, a very interesting hypothetical question was raised about the capabilities of our technology. The question was whether later on our telescopes could distinguish artificial light on another planet. For example, Proxima B, the closest exoplanet to Earth, around 4.25 light-years away, was acknowledged to be perfectly locked with a permanent dayside and nightside, like our moon. A hypothetical innovative development on Proxima B could move force and power from the dayside to the nightside using photovoltaic cells that make power from starlight. As a result, in a paper with Manis V. Ling as one of the researchers, it was shown that immense concentrations from the dayside by solar chargers could be related to future telescopes. Since the James Webb Space Telescope, JWST, was further developed, it would permit us to expand our search for artificial lights on exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope did exactly that in 2024, using its higher sensitivity and greater scope of capabilities, is earth-shattering. The JWST might have found the lights we were searching for and possibly hurled us into a new gigantic wave of human progression. Most importantly, we should delve into the universe of planets and exoplanets to figure out how this was even possible. Since the dawn of time, humans have contemplated the idea of the universe, what we are, where we come from, and where we go. These are ordinary yet extraordinarily difficult inquiries that humankind has endeavored to answer. When we gained awareness in the time of exceptional technological movement, one wonders whether we are any closer to answering these questions. If you were to ask a philosopher, he could say we are still at level 0 of understanding ourselves in the universe. However, ask a space expert the same question and watch him make the most of his energy as he rushes to tell you the most recent discovery people have made about the universe using their clever gadgets. These instruments, although not given much thought by the ordinary public, are directly an impression of human progression itself. We now have the world readily available, and it's time we push forward and get the universe at our fingertips too. One such method for doing that has been determined by scientists and space experts through the technology we tackle. A specific creation of that technology is now responsible for the new discovery of what might be light on an alternate planet light-years away. Yes, we're discussing the James Webb Space Telescope. The James Webb Space Telescope is the creation considered out of the traditions of human endeavors into space to address some ever-present questions. Are we alone? Who's out there? Where do we start and where do we end? This infrared space science gadget has already begun tending to these requests. Despite the fact that at first you could get yourself asking what Proxima B is, Proxima Centauri B, or just Proxima B, is sometimes alluded to as Alpha Centauri C. It is a super-Earth exoplanet and orbits an M-type star. Super-Earths could confuse you, but don't stress. This text will settle all your burning questions. Super-Earths are a class of planets that are more enormous than Earth but lighter than ice giants like Neptune and Uranus. They are truly one of a kind. They can be made of gas, rock, or even a blend of both, and their sizes can vary from 2 times the size of Earth to multiple times its mass. They really put the super in super-Earth. With respect to Proxima B, it is a super-Earth and an exoplanet, meaning that a planet orbits outside the nearby solar system. The first possible proof of an exoplanet was viewed as soon as 1917, although it generated little interest and affirmation. However, in 1992, the first confirmed detection happened, which left specialists shocked. Another exoplanet, first identified in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Of these, 896 systems have more than one planet. These sublime discoveries are surrounding an M-type star. To understand the M-type star, you need to sort out the red dwarf. A red dwarf is the smallest kind of star in the main sequence, hence the name. In the connecting areas of the Sun, red dwarfs are by far the most common kind of star found in the Milky Way. They have extremely low glow, and since luminosity is one of our main tools for planet location, red dwarfs are not so easy to notice. These subtle stars have variable definitions and names depending on their temperatures and sizes. For instance, M dwarfs or M-type main sequence stars yield a maximum temperature of around 3000 K, subsequently getting their name and characteristics. Getting back to Proxima B, its mass is known to be equivalent to 1.07 Earths. Interestingly, it only takes 11.2 days to complete one orbit of its star compared to our 365.25 days. You can estimate the size of the star Proxima B is surrounding. Amazingly, under the assessment of the entire electromagnetic spectrum, the star has a total luminosity of as little as around 1.6% that of the Sun. Moreover, in the visible light range, its glow appears to substantially dim more. It only shines 5 to 6% of the Sun's glow, low in the visible light range, emitting an extensively lesser amount of light energy compared to the Sun. Over 85% of its emitted energy is in infrared radiation, orbiting about 0.045 to 0.056 Australian dollars from its star. Proxima B's discovery was reported back in 2016. You might ask why Proxima B? With a million stars, planets, and worlds, why are we so focused on this particular celestial body? Well, there are a couple of reasons that add to the clear interest astronomers have in this place. Most importantly, Proxima B is the closest known star to our Sun, and by definition, although 4.2 light-years is a big number to us Earthlings, in the grand scheme of the universe, it is a simple blip. Hence, why Proxima B, our closest known star, is high up on the priority list. Right now, it is part of the triple star system called Alpha Centauri. In addition, although Proxima's luminosity is extremely low, the system itself appears as one of the brightest celestial bodies in the evening sky, just behind two others called Sirius and Canopus. Anyway, the most captivating thing about Proxima Centauri B is that it might actually be livable, as it falls within the habitable zone. The possible outcomes surrounding the star are endless, and thus astronomers have taken on the task to explore the depths and limitations of the star's true potential. That's where the James Webb Space Telescope comes in. The four key goals of the JWST are to search for light from the first stars and galaxies that formed in the universe after the Big Bang, study universe formation and evolution, figure out star and planet formation, and focus on planetary systems and the origins of life. As the JWST continues its examination of the said exoplanet, we draw closer to the culmination of these missions, from searching for exoplanets to searching for extraterrestrial life. So what exactly is SETI? One could ask. Considering that humans have always been an inquisitive species, examining and getting into literally everything that moves and doesn't move, it makes sense that a mission like SETI appeared on such a large scale. Imagine that God has orchestrated a grand, vast endeavor, but with a twist of gold. We are tasked with being on the lookout for signals, more specifically electromagnetic murmurs from civilizations beyond anything we might ever imagine. SETI, short for the search for extraterrestrial intelligence, resembles the world's most high-stakes game of hide and seek, with our planet as the searcher and the vast universe as the seemingly endless hiding spot. It is one of those fields where scientists are like advanced Sherlocks, tuned into radio waves and scouring for that subtle, we are not alone moment. This galactic sneaking around began eagerly in the 1960s. Frank Drake, a prominent astrophysicist, was among the first to detect radio signals from the stars. It was a historic moment, but no aliens arrived at his door just yet. However, as you may have guessed, Searching for something this big takes patience, and it can span decades. This quest requires scientists to connect the dots between millions of pieces of information scattered throughout the universe. Now, how does all of this tie back to Proxima B? A celestial body like Proxima B might be just one among many potentially habitable exoplanets found outside our solar system. The discovery of this planet and its atmosphere is extremely significant for astronomers. So, it brings about the ultimate question: could Proxima B be home to extraterrestrial intelligence? As the James Webb Space Telescope continues to provide remarkable insights, it keeps us one step closer to uncovering whether we're truly alone in the universe. This is just the beginning of an exciting journey, with much more to be discovered as we continue our quest to understand the cosmos. Proxima B stands as a symbol of humanity's unyielding curiosity and drive to explore the unknown. While the planet itself is not yet fully understood, the tools we've developed, particularly the James Webb Space Telescope, JWST, have provided unprecedented capabilities in studying distant worlds. These tools allow us to investigate the conditions of exoplanets like Proxima B with far greater detail than ever before, and their results have brought new questions and opportunities. One of the most remarkable features of Proxima B is its position within the habitable zone of its star, which is sometimes referred to as the Goldilocks zone. This is the region around a star where conditions may be just right for liquid water to exist on a planet's surface, considered a crucial ingredient for life as we know it. The exact conditions on Proxima B, however, remain uncertain. Its star, Proxima Centauri, is a red dwarf, which is much smaller and cooler than our Sun. As a result, Proxima B is much closer to its star than Earth is to the Sun. This proximity makes the planet's potential for habitability complicated, as it means that Proxima B may be subject to extreme stellar activity, including powerful solar flares and radiation, which could strip away an atmosphere and hinder the development of life. The potential for life on such a planet, therefore, lies in the details, whether its atmosphere can protect it from these harsh conditions, and whether liquid water can exist in the long term. In addition to studying its potential for supporting life, scientists are also deeply interested in Proxima B for what it may reveal about the broader universe. The study of planets like Proxima B allows us to understand the formation and evolution of planetary systems, particularly those around red dwarfs, which are the most common type of star in the Milky Way galaxy. By learning about these systems, we gain insight into how planets form, how they interact with their stars, and what conditions are necessary for habitability. As astronomers continue to observe Proxima B and other exoplanets, they will build a more comprehensive picture of the variety of planetary environments that exist beyond our solar system. Another exciting development is the growing interest in sending missions to explore exoplanets like Proxima B. While the technology required for interstellar travel is still far beyond our current capabilities, the idea of sending probes to distant stars has captured the imagination of scientists and science fiction enthusiasts alike. The concept of a probe that could travel to Proxima B, gather data, and send it back to Earth is a long-term goal that may one day be possible. Projects like Breakthrough Starshot, which aims to send tiny, light-powered probes to nearby star systems, are taking the first steps toward making interstellar exploration a reality. While these projects are still in the early stages, they highlight the ambitious vision for humanity's future exploration of the stars. In the meantime, the JWST's continued observations of Proxima B and other distant exoplanets will provide the scientific community with invaluable data that could shape our understanding of the universe for generations to come. By analyzing the light from these distant worlds, astronomers can detect the chemical composition of their atmospheres, search for signs of water vapor or methane, and identify other key elements that could suggest the presence of life. The ability to observe exoplanets in such detail is a direct result of decades of technological advancement and collaboration across the globe. The potential to discover life beyond Earth is one of the greatest scientific endeavors of our time. However, as the search for extraterrestrial intelligence, SETI, has shown, it is a pursuit that requires patience, persistence, and a willingness to embrace the unknown. Whether or not Proxima B or any other exoplanet is home to life, the search itself expands our understanding of the universe and our place within it. Every discovery, whether big or small, brings us one step closer to answering the most profound questions humanity has ever asked. Are we alone? What other forms of life might exist? And ultimately, what is our role in the vast cosmos? While we are still far from having definitive answers, the future of space exploration is brighter than ever. With the success of the JWST, the potential for discovering new exoplanets, and the ongoing advancements in space technology, humanity is poised to continue its journey of discovery, pushing the boundaries of what we know and expanding the horizons of our collective imagination. As we explore the stars, we may one day find that the answers to these timeless questions are more wondrous and unexpected than we ever imagined. The exploration of exoplanets like Proxima B not only provides insights into the potential for life beyond Earth, but also challenges our understanding of how life can thrive in diverse environments. Scientists are learning that the conditions necessary for life may not be as strict or uniform as we once thought. For instance, while Proxima B resides within its star's habitable zone, its extreme proximity to its red dwarf star creates conditions vastly different from Earth's, highlighting the adaptability of life to potentially unexpected environments. This expanding view of habitability suggests that life might be possible in places once thought inhospitable. Moreover, the study of Proxima B also contributes to broader astrophysical questions, such as planetary system dynamics, star-planet interactions, and the longevity of life-supporting conditions. By examining how planets like Proxima B interact with their stars, we gain a deeper understanding of the forces that shape planetary environments and what factors are crucial in maintaining stable ecosystems over long periods. As technology advances, new missions and telescopes will continue to refine our ability to detect signs of life, even if indirect, across vast distances. These ongoing discoveries underscore the importance of space exploration not just as a scientific endeavor, but as a step towards broadening humanity's understanding of its place in the universe.